So this video looks at graphing log functions. So we've seen the parent function in the introduction video, but just to go over it one more time. So the parent function here would be f of x equals log of x. And remember, if there's no base written there, it can be assumed that it's log base 10, because that's what your calculator deals with. So if I were to graph this, I know that when x equals 1, y equals 0. I had that from before in the introduction video. I have an asymptote here at x equals 0. And then my graph takes on this basic shape like this. Okay, so it's kind of like, it's actually an inverse exponential function. So my domain is going to go from 0 to infinity, not including 0. My range is from negative infinity to infinity. My intercept, so now I have an intercept of 1, 0, and my asymptote is at x equals 0. So you can see that everything is the inverse of an exponential function. So the domain and the range flipped. The intercept in an exponential function was 0, 1 instead of 1, 0, and the asymptote in an exponential function was y equals 0 instead of x equals 0. Okay, so let's see some examples of what happens when we shift the graph up, down, or left and right. So this one is log base 5 of x plus 1. So if I just want to sketch the graph, the base doesn't matter too much, but it can help me find a few points. So I remember that I know that if I have log base 5 of 5, that's equal to 1. So one of the points I might want to choose is what would make that true. So if I make a little table of values here, and I have x and g of x, so if I put x as 4, that would make this equal to 5. So I'd have log base 5 of 5, so that's 1. So I know I have the point 4, 1 here. And then if I choose at the point, I know also that log base anything. So log base b of 1 is equal to 0. So if I choose x equals 0, this would be 1. So I know that my y value would also be 0. I have this point here. And then what this plus 1 did was it actually shifted everything to the left 1. So it also shifted my asymptote that used to be at x equals 0 to x equals negative 1. And then I can just connect those points and have the basic shape of my graph there. Okay, so the domain of this graph is going to be now from negative 1 to infinity. I shifted to the left 1. That's what happened here with this x plus 1. My range is still from negative infinity to positive infinity. My intercept now, I only have the one intercept of 0, 0, and my asymptote shifted left 1, so my asymptote now is x equals negative 1. Okay, let's see another example. Okay, so I have log, when there's no base, remember, so it's log base 10 of x minus 1, and then minus 2 more. So what this is going to do is it's going to shift the graph, my parent function, 1 unit to the right. So it's going to shift right 1. And then this minus 2 is going to shift my parent function down 2. So if I start with my parent function, which is this one here, it'll shift everything as well. So it'll shift my asymptote too. So let's start with this. So I'm going to shift this main, I have this point 1, 0. I'm going to shift it right 1 and then down 2. So it's going to go right 1 and then down 2. So it's going to end up there. Maybe let's put in a new color. And then my asymptote also is going to shift to the right 1. So it's going to end up here at x equals 1. I can erase this. So I'll erase my parent function and I'll draw my new function. So it will look something like, so as I'm decreasing, it's approaching that asymptote and then it's going like that. Okay, so it should have kind of that curved shape. It's hard to draw on this iPad with this fat marker, but doing the best that I can. So the domain of this function is going to be now from from positive 1 to infinity, so I shift it to the right 1. My range is going to still be from negative infinity to positive infinity. So remember that as I'm going to the right here, I'm increasing, but just really slowly, but I will eventually, as x goes on towards infinity, I will get really high up on the y-axis as well. My intercept, So I will have an intercept way out here in the x-axis, and we can figure out what that is. So we can use the rules that we saw in the introduction video to change this from log function to exponential function. So if I'm solving for that intercept, I want to figure out, well, when y is 0, what is x, right? So I'll have log base 10 of x minus 1 minus 2. So I'll move the 2 over to this side. So I'll get 2 equals, that stuff now, so 2 equals log base 10 of x minus 1. And then I remember that I can change from logarithmic form to exponential form. So what I do is I take the base, so the 10, I put it to the answer, which is 2, so 10 squared is equal to x minus 1. So I'll have 10 squared, which is 100, equals x minus 1. So I add 1 to both sides, so x will be equal to 101. So my x-intercept is way down there. So you see that it's really slowly increasing. So I think maybe my other drawing was a little bit misleading. But my x-intercept will be at 101 and 0. So it's way down the x-axis. And my asymptote also shifted to the right one. It's going to be at now x equals 1. Okay, that's it. Thanks for watching. Good luck with the assignments.